Hello, we are the Yale Lab team and we will be presenting our solution for the Stretch Robot Pitch Competition. In trying to find a unique but wide-ranging application for the Stretch Robot for individuals aging with disabilities, we decided to combine virtual reality and machine learning to significantly help those individuals. These such individuals, due to their disabilities or due to their age, might have trouble with certain household tasks, either because the tasks themselves are strenuous or because the movement required of them is too challenging. This results in a lack of independence and freedom to some extent. To solve this problem, we have conceptualized a VR-based, remotely controllable robotic helper, the helper being the Stretch Robot. To break this down, we can start with a general overview of our solution. This process begins with the Stretch Robot's camera, which will intake the surroundings around it, and the user will use a VR headset, like the Meta Oculus Quest 2. Using a 3D VR video converter, we can take the Stretch Robot surroundings to render out a VR map of the user's home that the user can see through their headset. The user will also have a small patch of sensors on their forearm. In short, these sensors allow us to measure the muscle activity, movement, and position of the hand and arm. At this point, the user can do whatever household tasks they would like and mimic those movements with their hands, and this will also be rendered into their VR screen. This data will then be taken in by the machine learning model, which will take the movement of the user and translate that into Stretch Robot capable movements. Delving a bit deeper, we can further break down these steps and the function that VR plays in our design concept. The Oculus Quest comes with a feature that allows hand tracking, meaning that the user can see their own hands through their VR screen in real time. This is key to make the user feel as if they are doing the task themselves. The 3D aspect, as mentioned before, will allow the user to see their home in real time. In addition to the 3D map of their home, the user will also be given an arrow pad that will allow them to control the Stretch Robot's path. Once the location of the robot is set, then the user can press a button on their user interface that indicates to the machine learning model that the following movements the user makes will need to be translated so that the Stretch Robot can replicate them. In order to obtain this movement data, this is where the EMG IMU sensors come into play. These sensors, when attached to the forearm, can detect the kinematic movements of the user's upper limb. Bringing it all back together, our proposed design concept is a combination of 4 distinct components: VR, EMG IMU sensors, machine learning, and the Stretch Robot. This amalgamation of these aspects has the capacity to provide individuals aging with disabilities a greater sense of independence and freedom. The following are our team members. We are all members of Dr. Yale's research lab here at Georgia Tech. This lab's focus is human-centric interfaces and engineering to advance human healthcare. Here is our broad timeline for our proposed design concept. Over the next 6 months, hopefully we will have the chance to explore our project in greater depth. Thank you so much for your time.